Welcome back to Educator.com. Introduction to C++. Today we are going to loop. Okay, it's looping is involved with branching, and we've covered branching already. But this is a very important type of branching where you branch back to the beginning, do something over again. In early computers, there was an if statement and then go to another line, but we try not to use go-tos anymore. It's still in the language, but it's usable if you need it. Generally, you don't use go-to. We have a number of constructs that we use for looping. We have the while loop, a do while, a for loop, and there's ways of breaking out of a loop, and there's a way of repeating a loop. And of course, we have loops inside of other loops. Now, the differences we're going to discuss is the while loop checks the condition before going into the loop. Do while checks the condition after going into the loop. A for loop can be used like a while loop, but is usually used for a counting loop. But we're going to discuss all of this in a few minutes. Now we've seen code blocks, where we have our open brace, we have some code, and we have code, the closing brace. And we've used those to create a branch. So if A is less than 10, then we will run this code between the braces. If it's not less than 10, then we'll go into the else clause. Now what we're looking at is a looping branch. So we will run that same block again and again and again, as many times as necessary. So here we have a quick example. We're setting K and A to 0, setting B to 1, and we're going to ask the user for the value of M. And so we're going to increment K using the increment operator. We're going to add that new value of K to A. We're going to multiply B by that value. And then if K, our counter, is less than M that was entered, we will go back and we will run this block again. So like if M is 3, we'll change this from 0, we'll change it to 1. 0 plus 1 is 1. 1 times 1 is still 1. And 1 is less than 3. We go back around. Now we increment this again. It's 2. Now we have 1 plus 2 is 3. 1 times 2 is 2. And 2 is still less than 3. So we go back around. We make this 3. So now I've lost track of what A should be, but we're adding 3 to it. So I think that makes it 6. You'll have to write this out for your homework and test to see if I did this correctly. And then B gets multiplied by the new value of 3, which I believe is also 6. But if we were to go continue with 4, then we would get 10, and 4 times 6 would be 24. And so depending on what was entered for M, we will loop that many times based on K being incremented. Now, in early computing, all we had was the go-to statement. So we had that same code we just saw. So if J was less than 10, well, not the same exact, but something similar, we would go back to here. And at the end of it, we would output everything. And the reason why go-to fell into disfavor is people would sprinkle code with go-tos all over the place. We'd have a go-to in here, we'd have a test, we'd go to over there, we'd have a test, we'd go to up here. The code got very complicated very quickly, and the term used for it disparagingly was called spaghetti code. So if we avoid using the go-to, for the most part, we can avoid writing spaghetti code. So one of the first construct we're going to look at is the while loop. It's a pre-test, and it's just a basic loop. It performs a code block repeatedly. Now, as I mentioned before, code block can be replaced with a single line of code. You're not going to see that for the most part in these lessons, because I think you should get in the habit of always putting things inside your code block. Even if you could have one line, it's very often much better just go ahead and make a code block out of it anyway. So what the while loop does, it tests the termination expression, and that's your expression that's in the parentheses of the while loop. It tests it to see if it's true. And if it does this test before each loop through the code block. So the first thing it does, it has an expression here. Is A greater than 10? Is G greater than Q? Whatever. If it's true, then it goes into the loop. If it's false, it skips over that code block and continues on with the rest of the program. Now, one of the consequences of that, if you start off, if the expression is false when you first hit this while, this code in here will not get executed at all. So that's one of the things mentioned right here. So you have to be careful. Actually, it's something you very often you do want something like that. You have an expression that evaluates something, and if it turns out it's not true, you don't need to use this code. You skip over it. If it is true, you go into the code and you stay in that loop until that expression is no longer true. Now, there's also do while, which is a slightly different. It's the same type of thing. It's still a basic loop. Runs the code block repeatedly. The difference between the regular while is the test is done after the loop. And one of the consequences is that the code inside the code block will always be executed at least once, because it doesn't test the expression until after it gets to the end of the code block. So then if this expression is false, it'll just drop down to the rest of the program. If it's true, then it will loop back.